Hey, John here. Let's have a quick peek at the sizeof operator and see how it works. Here's a little program I wrote. What do we got up here? The usual includes. Okay, I also grabbed the standard int. Some usings so I can use the short forms of these various names. I create a class called tester that just simply has two variables in it, a 32-bit integer and another, it looks like an array of two, I should say. 32-bit integers, and then a single 32-bit integer. So this thing has a 8-byte array and a 4-byte value. We'll take a look closer at what that's all about in a minute. Okay, so here's my main function. I got a character, a short, and an int. They don't have any values assigned to them, but it doesn't really matter for this particular demonstration. Okay, so let's see what this thing is doing here. What's going on? I print out a string that says size of C, and then I print out the value of this thing, all right? Now notice that it looks like it, but size of is not a function, okay? It's an operator. So this size of C is an operator just like, say, the minus sign would be if you're typing in a mathematical equation. So the compiler will look at this and replace this whole thing with a literal value, which is the size of this variable expressed in bytes. So since the character we probably know is 8 bits in size, it's 1 byte long. If you print out this, it should say 1. All right, now the short and the int, as we know because of the standard int, the needs for standard int.h, are not well defined in C and in C++. What you do know is that a short is usually 16 bits or longer, and an integer is also 16 bits or longer, okay? So if we print these out, we'll find out how big they are on this particular machine. I happen to know what they are. We're running Linux on a, x86 class machine, therefore the character is going to be 1 byte. The short will be 2 bytes, and the int will be 4 bytes, okay? But if you run this on some other machine, that may not be true. How big is a float? We can print that out too. Now, notice the subtle difference here, okay? These are a size of, and I put the name of a variable in here. And this is a size of, and I put a data type in here. You don't actually have to have a variable in order to use the size of. You just have to have a thing that has a data type, or you have to have a data type, as I show down here, okay? So I'm going to print out a size of a float, a double, a long, all these are different kinds of things you can do in a C program. These are ill-defined as well. You never really know how big a long is or how big a long is, all right? Down here, when we got the standard integers, these are all known sizes. This will be 1 byte in size. This will be 2. This will be 4. This will be 8. Okay? Now, notice I can also say how big is an array of 4 int 16s. Well, that should be 8, right? Because an int 16 should be 2, and there's 4 of them, so this thing should be 8. I can also ask how big things are, like an entire class. How big is tester? Remember, tester up here is an object that has data values in it. So this is probably going to be 12 bytes, right? So let's go ahead and compile it. Looks like it's already compiled. And run it. Let's see what we got. Our character variable is 1 byte. Our S, remember, was the short variable. That's 2 bytes, okay? The integer variable is 4, okay? Like I said, on this particular machine, these things just happen to be that size. How big is a float? It's 4 bytes. How big is a double? It's 8 bytes. How big is a long? It looks like 8 bytes. How big is a long? That's also 8 bytes. Again, it depends on the kind of machine you're on. These are more portable types. These are exactly what we would expect them to be. And an array of 4 2-byte values should also be 8. Size of tester comes out to be 12 bytes. Let's take another close look at Mr. Tester here. Does that jive? Yes, it does, okay? But here's something interesting. What happens if I put one of these in here? You'd think that would add another 8 bytes to the size of this thing, right? So it should come out to 20. And yet, as we will see, it doesn't. It comes out to 24. Now this is due to a number of factors, okay? there's an extra 4 bytes hiding in here. Where did they go? It doesn't add up right. Well, it turns out that depending on how you configure your compiler, the compiler may define an object such that its size is always rounded up to the size of any single largest element in that class. Okay? Now, that's not to say that if I had a whole class that was a megabyte in here, that it would round it up to 2 megabytes, right? Because that other class is made up internally of integers and characters and so on. No matter what you put in the machine, it's really just a bunch of character shorts and ints and floats and doubles, okay? Those things, the biggest single object that you can define. Sometimes you have a quad float or a long float or a long double or something like that. That could be 16 bytes long. Let's see what that is. My point is, those are the sizes. Those are the things the compiler will use in its rounding. So let's take a look at 2 things here. First of all, our sizeof tester did go up to 24 instead of 20, and it's because it wanted to round it up to the size of the single largest, what I'll call the native data type, right? That 64-bit integer. Now, as we see over here, we have a long double, which is 16. So this is supported by this particular compiler, all right? All right, so anytime you need to know how big something is, you can use sizeof. But beware, if you're combining things, there are some other rules that you may not be aware of. You can even tell the compiler to not round this up if you wanted to. That's a little beyond this particular topic, but just thought I'd throw it in there to make sure that you understand what's going on if you run into a weird situation and things don't add up, okay? All right, so that's really how the sizeof operator works. Thanks for watching. See you next time.